Okay, so reflections. We have two reflections that we are going to worry about right now. So the graph of y equals negative fx is the reflection of the graph of y equals x across the x-axis. So what's going to happen is it's going to be these y points are going to change. So if this point, x plus y, is on the graph of fx, then x minus y is going to be on the graph of negative of fx. So we'll do this reflection first, and then we'll talk about the other one. Okay. So what we had said was that if we have a point xy is a point of the original function, then x minus y is a point of negative fx. And we said that we are going to reflect over the x-axis. Okay, so let me pick a point here. So just gonna move my graph out just a little bit here. There we go. Finally got to move. So this is sorry. This is the point 1, 3, and then over here is the point -1, 3. So I already put in the reflection over here. I just have to put it on. So if I do negative fx, we see that this graph is reflected down here. So this point ends up going down here, reflecting to this point. And the only part that's going to really change is this, that y coordinate goes from positive to negative. So this is what we talk about being a reflection over the y-axis. So this, sorry, this new function here would end up being is actually, let me put it up here. That's a little easier to see. The red one was, once again, y equals 3x squared. And then the green one is y equals negative 3x squared. So when you change that negative, what happens is just all your y coordinates change sign. So they went from positive to negative, except for this point here at 0, 0, 0 can't change sign. So that one stays the same. But as you see, everything is like a reflection over your x-axis. All right, so for the next part, now if we have the graph y equals f of negative x, this is going to be a reflection of f of x, but now across the y-axis. We'll show you why in here in a second. So if a point xy is on the graph of fx, then negative x positive y is on the graph of y equals f of negative x. So in this case, where the first one was changing all your y coordinates, their signs from positive, negative, negative to positive, this one's going to change all your x coordinates from positive to negative or negative to positive. All right, so let me label some points here for you. It was doing the scaling a little interesting. So this here would be 1. So this is a point at 1, 1. Once again, this is -1 down here. So this is a point at -1, -1. So what I'm using here is the function is going to be fx is going to be x cubed. Because I can't do a really reflection with x squared, which I can show you here in a bit. So like I said, now what we're doing is the negative is inside directly on the x. What we see is that my graph is flipping this way. Sorry, flipping this way. So this point is actually over here now. And it has changed to a -1, 1. So just the x changed. This point translates to over here. And now that point is going to be 1, -1. So as we had said before, if f of x is a point on fx, then what we should see is that the point negative xy is a point of the function f of negative x. And what we see is that this is the y-axis, reflect over y. Okay. And once again, this function over here would be f of x negative x cubed. Also, when you see it like this, because when we simplify, we like to get rid of parentheses. What we're saying is I have negative x times negative x times negative x. Well, what's going to happen is these negatives cancel. I'm just left with 1. So I have negative x times x times x. So this also can be written as negative x cubed. So we can pull that negative out of the parentheses. All right. And then I was to show you what's going to happen if you did this with x squared. So let me turn this off. So x squared, just to kind of point this out here, this is your point 2, 4, and I already have a point over here that is negative 2, 4. So some of these, when you do a reflection, it's just the same function back. As you can see, when I graph it, you don't see it pop up because it's right under that line. There you go. And just to explain why that happens, because this is something that comes up. If fx is squared, then f of negative x is going to be negative x squared in parentheses. So a negative times a negative comes out a positive. We get back x squared. So sometimes when you do a reflection, you're getting the same graph back. In this case, when this happens, it's because it's something we call it's properties of what we call an even function. All right, so this is just examples with a little more complex looking functions. So this is 3x cubed minus 4x squared. So the green is the original function. So it has a point here at 1, negative 1. So when I do my reflection right here, so I'm doing a negative out front to kind of express what this is. So this is negative out front. So it's essentially taking this function here and saying, I'm just multiplying it all by a negative 1. Well, if you distribute that across, that's going to be a negative 3x squared plus, sorry, 3x cubed, or 4x plus 4x squared. So that's how I get this function here. And then what happens is what we expect to happen with the blue function is that this point translates to that point because everything's reflecting over the x-axis. And this one, this required some fixing. So our function is x cubed minus 2x squared. So if we're going to reflect across the y-axis, that means we need to find f of negative x, which means that my negatives are all directly on my x's now. We're using that function notation. We're replacing all my x with negative x. So we already saw that negative x cubed would just be a same as negative the outside of the parentheses, x cubed. And then here, this x cubed, x squared, as we saw, because it's a negative times a negative, the negative disappears. So that's why we get this function here. The first term will change from positive to negative, but the second one stays the same. But you see that this point over here maps to that point over there. So let's say this point was, let me see, x is maybe 5. Say x is 5. We know y would be 0. That means this point over here would have to be negative 5, 0. because in this case, it's just coordinate changes from positive to negative. Right. So here we just have 11 and 12, which are just going to be some reflections. So to the right is the graph of y equals x squared. So you're going to do this transformation and then this one here, which we had already did, but like I said, do by hand, move those points and see what that reflection would be. So what I mean, do it by hand is pick your points, look at the reflection and show, like pick a couple points and show where they're going to reflect to. Then do the graphing. Okay, so like I said, we're just picking a couple points. So for this graph, we can easily see we have a point here at 2, 4, and then we have a point here at negative 2, 4. Sorry, I hit the wrong point. We have 0, 0. So we know that when we have this kind of reflection, what this is that, let's say this was f of x equals x squared. If I have the negative on the outside of everything, that means we're doing this kind of reflection. So in this case, what we're seeing is that your y coordinates are the ones that should be changing. Because remember, fx is just y, and basically I'm saying I'm multiplying y by a negative. So this point should transform down here to 2, negative 4. This point would go down here to negative 2, negative 4, and 0, 0 stays the same because you can't change 0 from positive to negative. It just stays where it is. So this would be my, do that a little smoother. Let me fix these a little bit. I think that my points are like a little off skew. Yep, right there. That happens sometimes. There you go. That would be your graph of that function. Like I said, we already done it. Just want you to just do it by hand, moving some points. All right, so for the next one, now you see the negatives on the inside. So if this was f of x equals x cubed, then when it's on the inside, we know that's the same as saying f of negative x, and that'd be negative x cubed. So in this case, it's x's are the ones that are getting the negative. So it's your x coordinates that are changing sign. So I have a point here at 1, 1. Once again, my point at 0, 0. And then my point here at negative 1, negative 1. Because of the transformation that I'm seeing here, my x's are changing from positive to negative. This point is over here now at negative 1, 1. This point is over here now at 1, negative 1. So it's just x's have changed. And then once again, the 0, 0 can't possibly change. And that's how you get that reflection. All right. So part of the reason we're using this is that we're going to talk about vertex forms of quadratics. And vertex form of quadratics, the equation is really highly based on the reflections and then those horizontal and vertical translations.